All right, you're welcome to today's class. Today we are going to take a look at chemistry. Chemistry. Please, I need silence, please. Chemistry. I'm recording this class. Please, I need silence, please. Then chemistry, what we are going to look at, as I said before now, I try as much as possible not to deviate from what you do in class. So any topic you think that I will see what you are taught. Then from there, I will not take it off from there. Maybe while explaining what you did in class to help you understand it better, I may go a step deep if I notice that maybe one or two persons are having issues, maybe a foundational issue. I mean, go deep to O level a bit on that topic for proper understanding. So that's the pattern we use in these tutorials. Then secondly, to help us not to go beyond, because it is of no point gathering you here and start teaching something that is different from what you did in your class, at least this short period. But but trust me, whatever you are going to learn today, it will open your eyes to, at your free period, to go deep, maybe if you need to understand the topic as a whole. So, from what I'm seeing here, you started with electronic configuration, right? So, what do you understand by electronic configuration? Arrangement of what? I need one person to talk. What do you understand by electronic configuration? Oh, yeah, say it out. Let's hear you. Oh, yeah. What do you understand by electronic configuration?
Is the arrangement of atoms in an orbiter in order of their energy level.
Is it the atom you are arranging? Or what? Electron. Okay. So in all, electronic configuration is all about in an atom, from the work starting from the work of John Dalton, coming down to J.J. Thomson, before at the end, Rutherford and Chadwick and what have you, they came to realize that actually, in fact, it was actually Rutherford that, did something that give us a clue of what atom is actually looks like, about having a positive nucleus and the positive nucleus, an electron revolving around it. Am I communicating? Now, these electrons, they are not just scattered anyhow around the positive nucleus. They are well arranged in different shells, different levels. So these shells, from the inner shell, outer shell to the outermost shell, these shells exist at different energy level. And this number of shells, starting from the one inside, K, the one closest to the nucleus, K, followed by what? L shell, followed by what? M, N, O, as case may be. Now, each of these represents different energy levels. And is designated with what? N. Named what? Principal quantum number. How many quantum numbers do we have? How many quantum numbers do we have? We have 4 quantum numbers. Did you do it in your O level? We have 4 quantum numbers. What are they? Number 1 is what? Principal what? Quantum number. Number 2 is what? They've forgotten. Child. Number 2 is subsidiary or azimuthal quantum number. Subsidiary quantum number or azimuthal. Subsidiary quantum number or azimuthal quantum number. The third one is magnetic quantum number. While the fourth one is spin quantum number. Now, as I said before, principal quantum number is represented by what? N, small n. Small letter n. Principal quantum number is represented by the letter small letter n. While subsidiary or azimuthal quantum number is represented by what? L. Small letter L. Then the magnetic quantum numbers is represented by small letter M. Then the spin quantum number is represented by what? Small letter S. I think I have actually explained the values of the principal quantum number, right? When I mentioned K, L, M, N, and each of them is numbered 1, 2, 3, 4, 5, as case may be. So if you now arrange them now, K has the principal quantum number of what? 1. It's like this. K has 1. It's actually like this. K, L, M, N, O, as case may be. This is the what? Shell. This is their quantum number, the principal quantum number N, right? This is 1, 2, K is 1, L is 2, M is 3, N is 4, O is 5. This is the main energy what? Level. Now, look at the structure of this of the atom. This is the nucleus, right? Positive nucleus, right? Then the electrons, this is the electron shell, right? This is the first shell, which is what? K, L, M, N. So what it means that this is actually the principal. When you mention the principal quantum numbers, you are talking about the main energy level, the main energy level, the principal energy level, the main energy level is what? The first shell is what? 1. Second shell, which is L, is what? 2. Third shell, which is M, is what? 3. And this one is what? 4. Now, in these shells, in these main shells, electron, there are number of electrons you can find in each of these what? Shells. There are maximum number of electrons you can find in each of these what? Shells. Am I communicating? There are maximum number of electrons you can find in each of these words. There is a formula. They say that if you want the maximum number of electrons, remember we are talking about how electrons are arranged in these shells. Remember, that's what we are talking about. Am I communicating? Yes, am I communicating? Who is lost? If you are lost, please ask question. Don't keep quiet. Okay? I believe for you to get to this level, you must have passed through this in secondary school. But even if you did not, due to one reason or the other, don't be discouraged. If you have any question, feel free to ask. That's why you are here. This tutorial is organized for people that are having issues. Someone sent me a message on WhatsApp that I'm having an issue on WhatsApp in chemistry. I don't know if the person is there. You are the one. So this is part of it. If there's something you don't understand, don't keep quiet. You do what? Ask question. There may be no special class. This is the special class I have for all the people that have been calling me, asking me to help them. I don't have extra time again. This is this is the reason why I organize this, so that if you are here, that question you don't understand, ask it. We are here. We are not rushing to anywhere. That's why I told you that this place, if you are too intelligent, if you are too if you know it all, you don't need to be what? Here, because most of the things we will do here, we will be drawing you back. Because I will try to look at that person that doesn't understand. You be doing, Saduna, let's go. I will not look at you. I focus on that person that is having issues. That's why I say that this is not for those that think that they have what, that they know it. It's for those that really want to do what. There are still people that have known it too, but they still want to know more. It's also for such people. Am I communicating? Yes, so please, this class is for you. If you don't know and you want to know, don't keep quiet. If you keep quiet, I will be following the tide of those that know. And at the end, you will lose out. Because even in class, there will be no time to be explaining all those things. Because it is expected that before you get admission here, before you present that O level you presented, it is expected that you are the one that wrote that exam. Because for you to get A1, B2 in chemistry, C6 in chemistry, you must know these things. Unless you know what's going on these days. Unless you're part of it. If you're part of them, even if you must have committed in the past, don't give up. That's why you are here. Okay. Now let's continue. Now, K, L, M, N. Now, each electrons are found in each of these shells. Am I communicating? Remember, we are talking about. You said that electronic configuration is the arrangement of what? Electrons. Good. So now, these electrons are not just scattered anyhow on the shell. They are arranged in a particular pattern, from one energy level to what? Another energy level. And these energy levels is represented by the what? The shells. This K shell is at a different energy level. Shell L shell, different energy level. M is higher than what? L. And these are designated by a number called principal what? Quantum what? Number. That's why you have N is 1 for this. Here N is what? 1. For L, N is what? 2. For M, N is what? 3. Now, in each of these shells, there is a maximum number of electrons you can find in each of these shells. And there's a formula you can use to know the number of electrons you can find in each of these shells. And this formula is what? 2n what? 2n what squared. This is maximum number of electrons you can find in each of the what? The maximum number you can find in each of the what? Shell. Am I communicating? Now let's take this K shell now. For K shell, n is what? 1. That means the maximum number of electrons you can find here is what? 2. 2 times 1 raised to power 2, which is what? 2. So here the maximum number for electron maximum you can find here is what? 2. Am I communicating? Then for L, it becomes what? This is what? 8. Then for M, it becomes what? 2 times 2 raised to power 3, it becomes what? 2 raised to power 3 is what? 3 is what? 2 times 2 times 2 is what? 8 times 2 is what? Now, if you go down again, if you go up, it keeps increasing. Am I communicating? Hello? It keeps doing what? Increasing. Are we there? Are we there? Now, but another point I want to make is this. Inside each of these shells, these electrons, there's inside each of these shells, that's what you also call what? Sub shells. Sub energy what? Levels. Sub levels. We call them sub what? Levels. Now, we call them what? Sub what? Levels. Now, but before we go on, have you heard of ground states and maybe excitation? When an electron loses energy, it drops down from a higher energy level to a lower energy level. When it's excited, it moves from a lower to what? Have you heard of such thing before? This takes place in the shells, in this shell, because these different shells actually represent the different what? Energy what? Level. So what it means is that electron can actually move from here. If it loses energy, it can move from here and drop down. And when it loses energy and get down to a lower energy level, that energy emitted is detected as what? as what? Line spectra. Have you heard of line? Have you heard of line spectra? Child. And this man, this scientist, Niels Bohr, the one you call Bohr, Bohr's atom, Bohr, is also one of the scientists that worked on this atomic structure development. From his work, in fact, he used hydrogen atom in his work. In his work, he was one that actually pointed out that the electron can actually move from a higher energy level to a lower energy level and vice versa. If it moves down, if it gets from higher to lower, it will lose what? Energy. And this energy is detected as what? Line spectrum. So it's pointed out that each of these atoms has its own peculiar what? Even though his own line spectrum, even though that his own work could not explain that of complex atoms. He could only explain that of what? Hydrogen atom. That's why sometimes they refer to hydrogen atom as what? Bohr's what? Atom. Am I communicating? So but his work actually opened the eyes of other scientists to see that actually electron can actually move from what? Higher to what? So this gave room for other scientists to work and led to other what? Discoveries on the arrangement and movement of electrons in what? I'm trying to explain what happened in different what? Energy what? Level. Now, having established that, now let us go down to look at this thing. Look at this thing. Let's work on n square. I'll tell you what n square is. Let's work on n square. Taking n to be, using this formula n square now. Let's work on this first one. For K shell, for K energy level. Here, for K what? N is what? For K, n is what? For K, n is what? 1. Okay, let me put that here. For K, this is n, this is what? N square, right? For K, n is 1. That means n square is what? 1 square, right? Which is what? For L, n is what? Which is what? 2 what? Which is what? For M, n is what? Which is what? Which is what? 8. 3 squared. Wait, coming here. What happened here? This is 3, sorry. This is 3, not 2. I made a mistake here. When we are talking about the maximum number of electrons here, it should be 3. 3 square is 3. 3 square is what? 9. It's 18, not 16. Please correct it. This is 18. I have no wonder. I was like, where is 16 coming from? I've not seen 16 before in my life. That's where the mistake came from. Please correct it, okay? Maximum number of electrons you can see in what? M is what? 18. But not all electrons you can, not all atoms get, is for higher what? Atoms. Either the atom with large atomic what? Number. Remember, hope you know that the atomic number is a function of what? All these things are a function of what? Atomic number. Hope you know.
Yes.
Hope you know.
Yes.
True or false? Good. Now let's continue. Now here is M is 3, so here is now 8. Now let's 9. Sorry, 9. This N represents the number of orbitals you can find in each of these what? Shells. This N represents the number of orbitals you can find in each of these what? Shells. Am I communicating? This represents the number of orbitals you can find in each of these energy what? Level. N represents the number of orbitals you can find in each of these what? Energy what? Level. What is an orbital?
It's a region of it's a space in the region of space around the nucleus of an atom.
That does what?
That contains electrons.
Is a what?
It's a region around the nucleus that contains that have the probability of locating electrons.
Is what? Say it again.
A region in space around the nucleus of an atom that has the probability of locating electrons.
The probability of what? Locating the what? Electron. Okay. Okay. Now when you talk of, by definition, is a region around what? Where we have the probability of what? Locating what? Electron. Am I communicating? What it means is this. In each of these shells, have you heard of, what do you think there's a relationship between orbitals and sub-energy level? Are they the same thing? What difference between orbitals and sub-energy level, sub-level? Is it what? Orbitals is what? Why subshell is where? Okay. What did you define as subshell for you people? Or explain as subshell? Okay. Now, when you come to, I want to explain this. In fact, everything we are going to, everything concerning this thing has to do with the 4 quantum numbers. If you know the 4 quantum numbers well, you can actually know how electrons are arranged. I'm not getting. So because of that, now I want to go to the 4 quantum numbers. Are we there? Yes. From this whole thing now, I want to now treat 4 quantum numbers. So put down something. Let's treat the 4 quantum numbers. With that, we can explain, because I can notice that everything we are trying to explain is pointing toward that. If you don't understand the 4 quantum numbers, forget it. You can never understand electronic what? Configuration. Just forget about it. You just cram the thing, but you only know why it is like that. So because of that, now I have explained what principal quantum number, right? Did you put something down there? No. Did you? No. So what I was explaining, you didn't put anything down. Mama mia. Okay, yeah, put something down. Put something down on principal quantum numbers. Now, there are 4 quantum numbers that define an electron within an atom. Have you seen it now? There are 4 quantum numbers that define what? An electron within a what? An atom. So if you don't understand the 4 quantum numbers, you will never understand how electron is arranged in an atom. And these quantum numbers are as follows. Number 1, the principal quantum number. It is represented with letter n, small letter n. So it has values 1, 2, 3, 4, 5, pom, pom, pom. It has values 1, 2, 3, 4, 5, pom, pom, pom. So the principal quantum numbers determine the energy levels or shells. I think I said that, right? Right? Did I? That's why I drew this and I drew here. Look at it on the board. The principal quantum numbers describe the what? Or what? Or what? Shells. The principal quantum number describes the energy level or the what? Shells. Very important. Now, as I also said that the maximum number of electrons in a particular energy level or shell is given by what? N raised to power 2 raised to power what? N what? Squared, right? Where N is the what? Where N is what? The principal what? Quantum what? Number. And I gave examples. I say for K shell, the maximum number of electrons is now what? 2 times 1 raised to power what? 2, which is what? 2. For L shell is 2 times 3 raised to power what? 2, which is what? 8. For M shell, 2 times 3 raised to power what? 2, which is what? 18. You can do that for the other shells. This is the maximum number of electrons. Maximum number of electrons each shell can do what? Contain. And I also say that the number, that each of these shells has the number of orbitals. There's that number of orbitals in each what? Remember, an orbital is a region in space where we have the possibility of locating what? An electron. Now, on these shells, we have each of these shells have each number of orbitals it can contain. Remember, it is the orbital that you see the what? You locate the what? We are describing how electrons are arranged in the around the nucleus of an atom, and we say that they are in different what? Energy level, and we define orbital as region in around that nucleus where you can locate what? Electron. So whenever there's orbital, you locate what? Electron there. Now, I now say that each of these shells has number of what? Maximum number of electrons they can accommodate. I get the formula. Now, where is that electron located? It's not in the shell, in the what? Orbitals, right? Now, each of these shells have the number of orbitals you can find in each of the what? Shells. And this number of orbitals is represented by which formula? N what? Squared. Is it clear? Yes. N squared is number of what? Orbitals in a shell, while 2n squared is maximum number of what? Electron in each what? Shells. That means in each shells, electrons are there, but these electrons in each of the shells are arranged in the what? Orbitals. Am I communicating? Orbitals are found in the what? Shells. Is it clear? Yes. These shells now, this is K shell, this is L shell. This shell, yes, it has maximum number of electrons it can accommodate, which is what? 8. But this maximum number of electrons are not just scattered like that. They are in a particular what? Orbitals. So there are about how many orbitals do you think you can have in okay, let's start from K shell. What is the maximum number of electrons you can find in K shell? How many orbitals can we find in K shell? 1 orbital. Can someone tell me what that orbital is? Yeah. The orbitals, that orbital, that one, it's one orbital in K shell, right? What's the name of that orbital? Good. Is what? S. So can we refer to orbitals as sub-energy level, sub-shells? Can we? Yes. Now, I threw a question before you. Learn how to pick points, different points, and merge them together and synthesize something great is a very important thing in learning. For those that say that they read, they don't understand or they don't maintain it, try to link up. Learn how to link up facts when you are reading. Sometimes something may not be explained to you explicitly, as in that directly. From linking up point, you can figure out something from it. Am I communicating? Yes. Now, what it means is this. This electron is found inside this what? Orbital, which is on the what? Shell. Am I communicating? Yes. Am I communicating? Good. So what it means is that even though we have main shells, electrons are in the shells. Okay, now let me use this yen as an example now. Let me use the yen as an example. Or different schools of pharmacy technician in Nigeria as an example. And let the different schools, or let Iyenu as a place, as a hospital, represent share, K-share. But you belong to where? So if you not come inside the Iyenu, yes, you're a student of Iyenu, but where do you belong? Iyenu. You belong to what? So let's take Iyenu as a whole as what? Share. Then inside that Iyenu, you have different sub-share. What it means are different schools, right? You are a student here, but where do you belong in this school? You belong to school of pharmacy technician. The same way, electrons are scattered. Electrons are on this shell. Electrons are here, but these electrons are here. With these electrons here, where do they belong to? Electron in K shell, because K shell has only one orbital. So the electron will definitely belong to what? S orbital. But what of L orbital that have more than one orbitals? That means different electron will belong to different shells. Oria, is it clear now? Remember, we are talking about arrangement of what? That you're a student of EN doesn't mean that you just be anywhere you like. No, you are somewhere in EN. You are in school of pharmacy technician. Somebody else may belong to school of dental. Somebody else may even be in hospital. The person will go to where he belongs to. The same way, when you come to this shell that have up to 18 electrons, these electrons here belong to different what? Sub-energy what? Level. Different sub-shells. Different orbitals. That's where they will go and arrange and align themselves. Am I communicating? Yes. Good. Remember, we are discussing arrangement of what? In an orderly what? Manner. Electrons are not just scattered anyhow on the shell. No, they are arranged from sub-shell, from the main shell, which is principal quantum number, which is designated by the principal quantum number to what? Sub-shell. Now, having discussed that, let's go to what? So, principal quantum number designates the what? Main shell, right? Let's go to what? The second quantum number, which is subsidiary or azimuthal quantum number. Subsidiary or azimuthal. Subsidiary or azimuthal quantum number. Azimuthal represented by the letter what? By the letter what? L. Good. Now, so subsidiary quantum number is represented by letter what? L. It has values. The value range from 0 to n minus 1. The value range from 0 to n minus 1. The value of the azimuthal quantum number range from 0 to what? To what? Good. Azimuthal quantum number shows the what? how many sub-energy levels. As the motor quantum numbers shows the what? The number of energy sub-levels in each shares. Have you seen we are going down now? From main share to what? Sub-share. So actually, as the motor number shows the number of what? Sub-shares. Am I communicating?
Yes, sir.
It shows the number of what? Sub-share. Principal quantum number shows the number of what? Shares, right? Why as the motor quantum number shows the number of energy what? Sub-shares. It shows the number of what? Energy what? Sub-share in each electron what? Share. Now, electrons, you can continue writing. Electrons, those electrons that have the subsidiary quantum numbers of 0, 1, 2, and 3. Right. I said that the electrons that have subsidiary quantum numbers of 0, 1, and 1, 2, and 3 are referred to as sp, d, and f electrons respectively. Electrons that have subsidiary quantum number of 0, 1, 2, and 3, they are referred to as what? S, P, F, and D what? Electron. S, P, F, and D what? SP what? SP. Sorry. I was saying something else. My pen was right something else. SP what? D and F. Sorry. I was calling SPD F. My pen was writing SPFD. SPD and what? F. I will derive a formula. I'll break down I'll do a breakdown on how we arrive at this. Am I communicating? But for now, just know that subsidiary quantum number is the what? Subshare. And they're represented with the letter what? L. Right? L. Now, and the value ranges from 0 to n minus what? 1. And electrons that have the subsidiary quantum number of 0, 1, 2, and 3 are respectively S, P, D, F what? Electrons. That is where they belong to. Am I communicating? Now, if that is the case, I want to do something. Let me now at this place. I think at this junction, I need to explain this further so you can understand how we arrive at it. Remember when we said that L for no one. Let me clean. Can I clean this board? Okay. Now what will happen is this. We write out K, the main shell, then the what? Subshell, then and their what? Value, the actual meaning of the number of the sub levels in each of them. Now, you can draw a table on your own. Just draw a table. Draw a table that has 1, 2, 3, 4. Okay, draw a table that has about 6 columns. 1, 2, 3, 4. Yeah, 6 columns. You know what is column, right? Column is this. This is row. Just column. Okay? See what I mean? Column 1, 2, 3, 4, 5, what? 6. Let this sixth one has more space. Am I communicating? Others may be equal, but let this one has more what? Space. Okay, sorry, let this third and sixth one. Let the third, 1, 2, 3. And sixth one, let this one and last one has more space because of what we want to put there. But others can have equal spaces, but let the third and sixth one have more what? Spaces. Now in the first column, the label title the first column, number of shells. Sorry, name of electron shell, name of shell, name of the shell, name of shell. You can name the electron shell here. Name of what? Electron what? Shell. Then in the second, you label the second one value of just n, just put n so you can accommodate, or you write value of n. But for want of space, if value cannot enter, just write only n there, okay? But if you can enter value, write value of n there, no problem. Then the third one, you write values of L. What is L? Good. Value of what? L. Here you write L. Value of L. Values now, because it's not one. Remember, values of L is a range. Remember, it can be a range. So you say that the value of L ranges from where to when? From 0 to what? N minus what? 1. Remember. So that means L for a particular shell. That means you can have more than one value of L for a particular what? Shell. That's why under a shell you can have different what? Sub what? Levels. Is it clear now? Good. Now, the third one, the fourth one, you write number of values of L. Each of this L has its own value. So number of values of L. Then the fifth one, you write number of sub-levels. Number of sub-levels. Number of sub-levels. Number of sub-levels. Then the last one, you write names of sub-levels. Names of what? Sub-levels. Now, with this, now let's go. We just walk from K to N shell and see what it will give us. Now, remember we have described principal quantum number and we draw it. Hope you remember. We drew a table for what? Principal quantum number, right? That time I wrote something like this. That was a table I drew for principal quantum number. That time I wrote something like this, but I wrote something like this. I told you here is what? K what? L M N, right? This is what? Shell, right? This is what? N is what? 1, 2, 3. For this is actually what? A table. Is it clear? And I drew. So this one is for principal what? Quantum numbers. So we are this second one now. We want to integrate the what? The azimuthal quantum number, right? Now, so that means this second table now contains both the principal quantum number and the what? True of us, because we are starting with the principal quantum numbers. So here now you write the first one. You write the first one. Here, number of shells. You write here K. Here K. K. What is the value of N for K? 1. Good. Are you following? So the value of K, N for K level is what? Okay, let me complete the whole level. This is L, M, and what? And this is what? This is what? 4. Good. So K is 1. For N for K is 1. N for L is what? 2. N for M is what? 3. N for N is what? 4. Then after that, now let us go to the values of L for each of them. Remember we said that they will stand up, we are sleeping. Remember we said that the values of L, that is subsidiary quantum number, ranges from where? 0 to what? N minus 1, right? So if it ranges from 0 to N minus 1, what are the values of this L for K shell? Who can tell me? Let me know someone that thinks deeply. Huh? 1 minus 0. So it's what? 0. So it has only one what? L has only one what? Which is what? It has only one value, which is what? 0. Are you there? It ranges from 0 to N minus 1, but 0 is already there. But N minus 1 is what? For K is 1 minus 1, which is what? 0. So for K is what? 0. Then for L, what do you think for this second shell, when N is 2, what do you think should be the range for this L? 1. It's a range. They say 0 to N minus 1. So what should it be? 0, 0 and 1. 0 and 1. 0 and what? 0 and what? They said 0 to what? N minus 1. So this 0 is inclusive. So it should be 0 and what? 1. But for K shell is only what? 0. Is it clear? Then work for the fill in the other one. For M shell is what? 0 what? No. 0 what? 0 what? 0 what? They said 0 to N minus 1. So 0 is there, 1 is there, to last value of N is what? 3. 3 minus 1 is what? 2. So 0 to 2. That's the meaning. They said 0 to N minus 1. N minus 1 is what? For M shell. N minus 1 is what for shell M? So 0 to 2 is what? What does 0 to 2 contain? What does a range of 0 to 2? What does it contain? Now. So this is what? 0, 1. They say it's a range from 0 to N minus 1. It's a range. I mentioned range, you put it down, so you don't understand what you put down. Mama mia. I said it's a range. It ranges from 0 to what? N minus 1. So if N is 2 here, 2 minus 1 is what? 1. So from 0 to what? 1. That's why you have 0 and 1. Here, N is what? 3. 3 minus 1 is what? 2. So from 0 to what? 2. Here, N is what here? For N shell. Principal quantum number is what? 4. So L value should range from where? 0 to what? 3. So 0, 1, 2, and what? 3. So this is 0, 1, 2, and what? 3. Do you understand it now? Do you understand it now?
Yes, sir.
Good. So that is for. It continues for the rest of the other words, shells. So, but let's stop here. Now, let's go to the next column. Hope you are seeing how we are building this column. You don't have to cram it. Don't cram it. Just learn how to build it. Now, we have described principal quantum number. and the azimuthal quantum number. Let's finish up with the azimuthal quantum before we go to the next quantum number. Now, what did I say should be in the next column? Number of what? So, what is the number of values of n here now? Number. As well as the number of values is what? Number is 1. L has 1 value. 2 of us. This is what? 1. Here, uncle. 2. Here, uncle. For M is what? Because M has 0, 1, 2. So it's 3. Right? L has 0 and 1, which is now 2. But K has only 0, which is what? 1 value. Now, what of here? Number of values here. N is what? 4. Here is what? 4. Now, let's go to the next. What is the next thing in the column? Number of what? Sub-levels. Number of what? Sub-levels. Sub-levels. So, the number of values of L per each cell indicate the number of sub-levels in each of the what? Share. So, in first share, what's the number of sub-level in this share? Is what? I said that the number of sub-level is same thing with the number of L, number of value of L in each cell. Number of sub-level in each cell is certain as number of what? Value of L. So what should be the number of sub-level here is what? 1. So what it means is that K shell has 1 what? Sub-shells. Is it clear? What of L? L is what? 2. What of M is what? N is what? 4. Now, what is next in the column? Now, their names. We name them one after the other. Names of what? Sub-level. For K, has only 1 sub-level. So the name of that sub-level is what? S. S sub-level. Is it clear? Then L has 2 sub-level. Their names are SP. Good. S and what? S and what? P. Or simply S, comma what? P. M has 3 sublevels. What are they? S, P, D. Then N has another sublevel. 4 sublevels. What are they? Are you beginning to understand this section now? Because I have come to where you started in your class. So that's why I decided to go down to quantum so you can understand what you did in class. Do you now understand where all this came from? Yes. Let's go to the next quantum number. The name is what? The magnetic quantum number. The magnetic. Have you now seen that the principal quantum number talks about the number of shares? Azimuthal, not sub what? Levels, right? Right? Yes. Now let's go to what? Magnetic quantum numbers. Magnetic quantum numbers. Magnetic quantum numbers is represented by the small letter m. Magnetic quantum number is represented by the small letter m. Magnetic quantum number is represented by small letter m. The magnetic quantum numbers ranges from -1 through 0 to 1. Orbitals are found under what? Subshells. Okay? We have shell. Look at it. See how it works. We have shell, subshells, and what? Orbitals. Am I communicating? Shell first, which is described by what? Principal quantum number. Subshells, which is described by what? Then orbitals, which is described by what? Magnetic what? Is it clear? Then I said that the magnetic quantum numbers is represented by letter what? Small letter what? M. And it describes the what? The number of orbitals in a subshell. Are you there? It describes the number of orbitals in a subshell. What is it? You are looking at me as if you are.
You said it's
Okay, sorry. I have a very big problem. Do you know my faults? The taking note is my faults. So if you are in my class, try to understand it, because I may say one thing in 3 different ways. So if you're waiting for me to dictate for you to put it down the way you are, you may be there. I will say a different thing altogether. But if you understand what I'm saying, you can put it down in way you understand it. Is it clear?
Yes, sir.
Please, I think that's what happened to you now. Okay, where this stuff? Let me dictate the way you were writing. Where this stuff?
It ranges from.
Okay. It ranges from what? -1 through 0 to what? 1. Is it clear? From what? -1 through 0 to what? 1. Now, I'm saying that it describes, it shows, it represents, anyone who chooses the number of what? Orbitals in a subshell. Is it clear?
Yes.
It shows, it represents, it designates of number of what? Orbitals in a what? Subshell. So what actually talks about the number of orbitals is what? So what it means is that orbitals are found under subshells, while subshells are found under what? Shells. Is it clear? Remember, we define orbitals as region where you can locate what? Electrons. So electrons are actually located under what? Subshell. This is how electrons are arranged in a shell. In a shell, we have different subshells that make up a shell. That is, different orbitals make up a what? Subshell. Isn't it amazing? I mean, I say that an electron is not actually scattered in a subshell. Now, we can take shell as hospital. We can take subshell as school of pharmacy what? Technician. Then we can take orbitals as first year class, second year pharmacy class, second year pharmacy class, and third year pharmacy class can be what? Orbitals that make up the subshell, which is what? School of Pharmacy Technician. That make up the shell, which is what? With other schools, which is what? Schools in EN. Is it clear now?
Yes,
Is how electrons. So you are the electrons that are arranged in this school like that. So we human beings are the electrons here. But we are not just scattered. We are arranged from subshell, from orbitals, which is different class you are in, to subshell, which is different schools. Different schools in EN, then main shell, which is what? EN what? Hospital. I just use what you can see or what you know to describe how electrons are what? Arranged. Now, we will draw another table to now describe this, our range from 0, -1 through what? 0 and what? 1. We'll draw another table that talks about the orbitals. Now, we are not talking about the orbitals, right? Now, draw another table that has 1, 2, 3, 4, 6 columns again. 6 columns again. As you are drawing it now, the third column should be largest. The space of the third column should be larger because it will accommodate many things, okay? Now the first column, you write value of L. First column, write value of L. First column, write value of what? L. Second column, write name of sub level. Name of what? Sub level. Name of what? Sub level. So we draw. Can you see the board clearly here? So we have 1, 2, 3, 4, 5, 6, right? Here we have value of what? L, right? Here is what? Name of what? Sub level. Then followed by value of M. Value of what? M. Values, not value, values of M. Then the third one, number of values of M. Number of values of M. Number of values of M. Then the next one, number of orbitals. Number of orbitals. Then the last one, names of orbitals. The last one, names of orbitals. Now let's go back. Value of L. We can pick it from here. You see how these things are working. Watch out. Look up. We first did share. So but when we are doing sub energy level, we borrow some part of that name of share. So we can understand it, right? Now that we are talking about orbitals, now we also borrow some part of this what? Sub what? Level. So we'll start with name of what? What are the names of what? The first column is what? Values of, what are the values of L? 0, 0 and 1, 0, 1, 2, The number of sub-level is what? 1, 2, 3, then 4. Then next one is what? Values of what? Of what? M. Values of what? M. Values of what? M. Remember I said that M ranges from what? -1 through what? Through 0 to what? 1. -1 through what? 0 to what? 1. Are we there? -1 through what? 0 to what? M. 0 to what? 1, right? What it means is that if it is one value is 0, right? Now, if it is one value, if L here is one value, that means this one has only what? 0. Are you with me? This one has only one value, which is what? 0. Are you with me? Then, if it has two values, that means it has -1, as in -1 negative and +1. Are you with me? 0 will remain in the what? Center. But it takes from -1 to negative what? Positive what? 1. Is it clear? The 0 will still remain what? In the center. So here now for 2 we have what? -1, 0 what? 1. Are you with me? Then for 3, what it means is that, what do you think it should be for 3? What? Say it again. Minus what? It will start from -2, -1, 0, then -1, Sorry, minus 2, minus 1, 0. Minus 1 and what? 2. Are you with me? This is 2 values, right? 2 values, right? You have 1. Look at it. This is 1. 0 here is enough to be 1, right? This is 2 value. This 0, 1 is a value. Then minus 1. Are you with me? Then this side again, this 0 and 1 again to this side. To this side. Are you with me? This 0, 1 is 0, is 0 is there intact. But 2, you count 2 in positive side, the same counting negative side. Are you with me? Now, so it's 2. So you count 2 from this 0, but you add 0. 0 and 1 this side is 2 is completed this side. Then the positive side, the same 0 and 1, 2 is completed what? The other what? Side. Now the same thing with this 3. You still put your 0 in the middle. Count 3 this side from 0, 1, 2. Then 3 again, 0 minus 1 minus what? 2. Do you know your number line very well? Yes. Why look at me as if you don't know your number line? In number line, 0 is at the middle, right? Yes. They are trying to say that in each number you are counting, you add 0, but you count from 0 left that number. Count again from 0 right that same number. 0 is here. This is 1. That 0 has been for this one. 0 has been 1. They are not as you are counting again. But for 2, 0 will still be there. You count from that 0 to that side. 0 and 1 are 2 values. Then 0 and minus 1 are what again? The same 2 values, but to the what? Left. Now, for this 3, you do what? You count again. That's 0. 3 values. 0, 1. In positive direction. 0, 1, and 2. You also count in negative direction. That same 0. 0, minus 1, minus 2. Is it clear? So, you can say, okay, let me not make it confuse you, because most of you don't even, if you count this your numbers, it gets to confuse them. I can put minus 1 here. Here now I can now say what? The 0 is here, right? You have minus 1, minus what? 2. We have counted 3 in negative in this side, but actually it should be here. Negative should be here. Here, please, let's maintain it. I was trying to explain, that's why I put something there, but it's wrong. It should be here. For the positive side now, you count 3 values. 0, 1, and what? 2. Then you also count negative side, which is what? 0, minus 1, minus what? 2. Is it clear now? Now for this 4, sub-level 4, 0 should also be there. Then you count 4 values from 0 to the right. 0, 1, 2, 3. Then you also count from 0 to the left again. 0, minus 1, minus 2, minus what? 3. This is how it should look like. The same thing, you will do the same thing for each of them until the last shell. Until the last one. Remember, as you extend this one will also do what? Increase. This one will also do what? In fact, feel it in yourself. It will help you. Okay? Now, this is the values of M. So that means for sub level 1, for this sub level, M has only 1 value. For this sub level, M has how many values? 3. Has how many values here? 1, 2, 3, 4, 5. Has how many values here? 1, 2, 3, 4, 5, 6, 7. Is it clear? Is it clear? Good. Now, having done that, what is next? What is next column? Huh? Number of what? Number of values of m. So let's put it. What is number of values of m here? 1, right? Here is what? Good. 3. Here is what? 5. Here is what? 7. The same thing, you can fill the others. Is it clear? Now, having determined that, this number, the same way, this is number of value of L. Look up. Go back to the sub level. This is number of value of what? L. The same way the number of value of L represents the number of subshells. The same way the number of value of what? L represent the number of what? Subshell. The same way the number of value of M represent the number of what? Orbitals. Is it clear? So this one now is number of what? Orbitals. So number of value of M is the same thing with number of value of what? Number of what? Orbitals. So here now, what is the number of orbitals here? One is right. What is the number of orbitals here? What number of orbitals here? Here, Uncle. 7. We are arriving at somewhere. There's something is coming out now. Let's complete this before I say what I want to say. Next thing is what? Names of orbitals. So names of orbitals is what? This one is what? S orbital, right? This one is what? P orbital. This one is what? This one is what? This is the number of orbitals. P orbitals has how many suborbitals? 3. See them here. How many electrons can we find in a p orbital? 6. In a suborbital, how many? 2. In p suborbital, how many? 2. Oria. Don't know what is a suborbital. Don't know what is suborbital or degenerate orbitals. Hey. Don't worry, we'll get there. Maybe I'll find a way to explain that. We are arriving at somewhere. So we have done with what? Magnetic what? Quantum. So magnetic quantum number talks about the what? Number of what? Orbitals. Let's go to the last quantum number. The spin quantum number. The spin quantum number. By the time we are done with spin quantum number, that's when you appreciate this electronic configuration very well. The spin quantum numbers. The spin quantum numbers. So the spin quantum numbers describes how electrons spin on their axis in an orbital. The spin quantum numbers describes how electrons spin on their axis in an orbital. So an orbital actually has how many electrons? 2. And they spin in opposite what? Direction. Are you with me? Electron has, an orbital has 2 electrons. Look at it. Look at it. That spin in opposite what? Direction. This spin half. This is minus half and plus what? Half. That's why 2 of them make up a pair. Is half. Half. This spin in left side minus half. The other one spin in positive side plus what? Half. This is what spin quantum number is all about. It describes how that electron, how in that orbitals, how the electrons are arranged inside that orbitals. He said that the electrons are arranged in that they spin in opposite what? Direction. One spin to the left, and the other one spin to the what? Right. That number, magnetic quantum numbers are minus half and plus what? Half. That's sorry. Not magnetic, spin what? Quantum what? Numbers. Plus half and minus half. Denoting that electron. That's why this is wrong in chemistry. You don't do it like this. So it's wrong. Okay? This is not how. This is complete. Are you with me? So this is the right way to do what? Represent it, not this thing. Okay? Please, this is the right way. That's why this actually represents the half. Minus half in this direction, plus half in what? Opposite what? Direction. This is how electrons are what? Spin. Now, this is the what? An orbital, right? An orbital has two ends. So this orbital now, let's go back to here. Let's use this to describe this. For s orbitals that has only one, so s orbital is like this, right? Good. Because it has only one what? One what? One what? What did you call this? Orbital, right? It has one what? Orbitals. Yes? Right? So, but for p orbital, it has what? For d orbital, it has what? 2, 3, 4, 5. This one is s orbital. It's just orbital on its own, right? This is p orbitals. These 3 orbitals that are under p orbitals are called degenerate orbitals. So p orbitals has 3 degenerate orbitals. What it means that orbitals of the same what? Energy what? Level. Degenerate orbitals are orbitals of the same what? Energy what? Level. Degenerate orbitals. So P has how many degenerate orbitals? How many degenerate orbitals? D has how many degenerate orbitals? 5 degenerate orbitals, right? And in each degenerate orbitals, the maximum electron you can find there is how many? 2 electrons, right? In each degenerate orbital, the maximum electron you can find there is how many? 2. And the spin, remember spin quantum number, they spin in opposite what? Direction. In p orbitals, you can have 3 degenerate orbitals, and in each orbital you have maximum of how many electrons? 2. You see 4?
No.
2. And they spin in opposite what? Direction. Bam, 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 bam. Have you now seen why the number of electrons you can find in P is 6? Maximum is 6 electrons. Maximum here is what? 2. True of us. Why maximum here is what? In D is what? Is what? Is what? I always explain what you have in your notes. Check your note well. S is what? How many? P is what? D is what? Is it clear now? Is it clear now? So these are called degenerate orbitals. Those 3 degenerate orbitals in P are called X, Y, Z. P what? X. True of us? P what? And PZ. They have the same what? They have the same what? Energy what? Level. These are the 4 quantum numbers. These are the what? 4 quantum numbers. These are the 4 quantum numbers. Remember I told you that the number of orbitals in a shell is represented by what? N squared. Okay? Let's check whether it's true. Okay. K orbital, K shell. Number of orbital in K shell is what? Is what? If number of orbitals if number of orbitals in a shell is n squared, not 2n squared is number of maximum number of electron. No, we are talking about orbitals. Number of orbitals if the number of orbitals in a shell is n squared, therefore for K shell number of orbitals there is what? 1 square, which is what? 1. Let's check whether it's true. Look at K shell. How many orbitals does it have? How many orbitals? See it here, it's 1, right? Right? 1. This is number of orbitals. Hope you know. Hope you know. This the number of this that one is what? Subshell. This is orbital. So K, remember this K extend to here. Hope you know. Hope you know. Look up. Look what are you writing? Look up. Look up. Oh, what are you writing? I say, sure, you know that K extend to this place. Hope you know. Okay, this is the condition of what? K. Hope you know. Are you aware? So K has what? 1 what? Orbital. So n square is what? 1. So then L has what? 2 raised to power what? Which is what? 4. Let's check whether it's true. Let's check whether it's true. A shell has different subshell, right? Now, K shells. This is K shell, right? This is L shell. So L shell is what? This second one is L, right? L shell is what? This 3 plus this 1. Remember, is under it. 3 plus 1 is what? 4. Let's continue and see whether it is true or not. We cannot stop here for now. Now, for M, it becomes what? 3 raised to power what? Are you following what I'm saying here? Are you actually following me? Are you? I don't think so. It becomes what? What? 2. It becomes what? 9 orbitals, right? Let's check whether it's true. Here, this is M, right? 5 plus 3 is what? Plus 1 is what? So it's true. Let's check for what? N. N is what? 4 raised to power what? Which is what? 16. Let's check whether it's true. Let's count. 7 plus 5 is what? Plus 3 is what? Plus 1 is what? So actually, the number of orbitals in a shell is n squared. So the principal quantum number squared will give you the number of orbitals in a shell. Let's clap for ourselves. Let's clap for ourselves. Did we achieve something today? Yes. Now, having done that now, we have described how electrons are arranged in an atom. Let me summarize it. Let me summarize how electron is arranged in an atom. Electron is first arranged in degenerate orbitals, in pairs. Right?
Yes.
Degenerate orbitals come together to form an orbital. But there are some orbitals that just have only one degenerate orbital, like S orbital, right? Okay, yeah? But P has 3, D has 5, right? Now, these degenerate orbitals come together to form the main orbital, right? Now, these orbitals now are now arranged in a sub-shells. Now, sub-shells are arranged in a what? Shell. So we have different shells in an what? Atom. This is how electron is what? Arranged. Now, what are the rules that guides this arrangement? This arrangement is guided by set of rules. This arrangement is guided by set of rules. So we'll stop there for chemistry. Go and assimilate this one. In our next chemistry class, we'll talk about these rules that guides how electrons are arranged. Is it clear?
Yes.
So we'll stop here for chemistry. Let's do 1 or 2 things in mathematics before we go. All right.